Welcome to Spring LIB.
Let's say this is Earth. Now Merak, the star, is at a distance of 77 light years from Earth. Let's call this M stands for Merak. Let's denote it like that from now on. And we know that the star Alkaid is at a distance of 138 light years. But it is at an angle of 25.6 degrees compared to Merak. This is Alkaid. Now we want to find the distance between Alkaid and Merak, this distance. Now let's say this vector, the distance vector from Earth to Merak is m bar, and the distance vector from Earth to Alkaid is a bar. Now we know that because of the way we chose our coordinates, if horizontal direction is x-axis and vertical direction is y-axis, the Merak vector would just be completely on the x-axis, and hence it would be 77i. Of course, the units are in light years. Now, the Alkaid vector would be 138 cos 25.6 I cap plus 138 sine 25.6 j cap, because the angle here is 25.6 degrees. This, if we plug it into a calculator, turns out to be 124.4 I cap plus 59.6 j cap. Now we know that the distance vector from Merak to Alkaid is a minus m, which gives us 124.4 minus 77 I cap, because they are the x components, and then we have the difference between the y components, which is 59.6 minus 0 j cap. This turns out to be 47.4 I cap plus 59.6 j cap. Now to find the distance between Merak and Alkaid, we need to find the magnitude of this vector. Now by using Pythagoras theorem, we can see that the magnitude of this vector is square root of 47.4 squared plus 59.6 squared. This turns out to be 76.15 light years. Now part B is where we want to find out the angle subtended by Alkaid and Earth at Merak. Let's call this angle theta. Now let's draw this diagram again. We know that this is theta and this is 25.6 degrees. Now, if we find this angle, we know that the sum of these two angles, theta and this angle, would be 180, and we can find theta. So to find this angle, we know that this is the vector a minus m, and this would be its y component, which is 59.6. And this would be its x component, 47.4. If this angle were alpha, then we can say tan alpha is the opposite side divided by the adjacent side, which is 59.6 by 47.4. Hence, alpha is tan inverse 59.6 divided by 47.4, which turns out to be 51.5 degrees. Now we know that theta plus alpha is equal to 180 degrees because they are on a straight line. Hence, theta is 180 minus 51.5 degrees. This turns out to be 128.5 degrees.